We're going to talk about automating measurements with pScheduler's Batcch Processor. I'm not going to bother to introduce myself because I think you know who I am by now. I will start by saying this is kind of advanced material. It is not required for everyday use of perfSONAR unless you're into this sort of thing. What I am going to assume here is that you have some knowledge of pScheduler's basics, how it works, what it does, all that sort of thing. You understand the JavaScript object notation. There's actually going to be a lot of that in this presentation. And optionally, an understanding of the JQ scripting language, which is used to do processing on JSON. If you don't know about JQ and you want to learn about it, there is on our YouTube channel, you'll find a seminar that's, I don't know, about an hour and a half long, that covers it in great detail. We did that a few years ago, and everything in there is still relevant to all this. So let's dive right in. I always start these things with a definition slide. I don't know why, but I do. So batch processing is the running of jobs that can run without end user interaction or can be scheduled as resources are available. The part of this that we actually care about is the without end user interaction, largely because the scheduled as resources permit part is already something that pScheduler does no matter how you run your measurements. So the next question is, why is this useful to anyone? It's really useful, as we were talking before about having things like standard tests that you stuff in a JSON file someplace and have the command line import. Running standard sets of measurements are probably a useful thing, both from sort of a user standpoint and a programmatic standpoint as well, because people do write things that integrate with pScheduler. Prior to the batch processor existing, this came to exist, by the way, in the 4.3 release that we did a year ago. And prior to this, your choices were kind of two. One was to do it manually, which is kind of tedious and is kind of error prone, or roll your own. And I'm sure probably some people had done that for a few things. The origins of this are in a thing called Peashooter, which kind of came up, I think, in an earlier talk briefly, or maybe during the questions and answers. But that all started back at TechX 2018, where I gave a little talk and demo about it. And Peashooter is a thing for doing automated troubleshooting, where it does a trace between a pair of hosts, and then it goes to find the perfSONAR nodes along the path. And this is sort of where we stumbled, because we actually came up with a system for this and never really promoted it to get the people who needed to be involved to put things in DNS to make this happen. We may do that at some point, because I think it is still a useful tool. And then once you understand what the perfSONAR nodes along the path are, then you just do a test from the origin to each point and burp the results back out, and that can be used for things like handing back to a network operator that says, hey, we saw this problem, here's what we've already looked at, maybe that'll help you solve the problem a little bit. In 2019, we turned it into a product. It is actually built. I'd actually have to check and see if it's in the distribution. And if you want to see the talk that I gave at TechX 18, you'll find that at the link below, and you'll be able to download these slides after perfSONAR Day is over with. The other half of the origins for this, and really this is kind of what brought it to fruition, was Internet 2's next generation infrastructure project. Last year, we were doing some evaluation of systems to put in our POPs, and these were going to be relatively kind of beefy utility machines that had, among other things, a pair of 100 gig Ethernets on them. The first of those 100 gig Ethernets was going to be for internal use for our performance assurance service. This replaces a whole raft of machines that have been in our POPs for many years and were just kind of due for replacement. And the other interface, the planned use for it is to make it available to our members, to R&E at large, and quite possibly the public for use as well. We haven't figured out what the access rules are going to be for that, but I'm sure we'll come up with something useful. In the process of doing that evaluation, because we wanted to evaluate this thing in a whole bunch of different configurations with kind of different network cards and perfSONAR and bare metal versus what we ended up doing, which is embedding a pair of them in Docker. Matt Zakauskas developed a test battery for doing this that we wanted to be able to run with the machine in the different configurations and compare the results. And somebody kind of rattled my cage about it and said, how can we automate this? kind of the first thing you think is scripts, and that seemed like a little bit of a clunky solution. So me being who I am, I decided that we needed a more general solution to make this into kind of a useful general purpose tool. So from that came kind of the Mark I version of the batch processor. And it was a fairly simple creature. You'd give it a list of tests that it would ingest. It would hand each one to pScheduler in succession and collect the results and provide them. Well, this was good, but it was not quite what we needed. So that sort of that led to the Mark II batch processor. And again, that was driven by a lot of things that were in Matt's test battery. There were a lot of things where there were a number of things that were repeated globally. And there were also things where Matt wanted to do the same measurement with, say, progressively larger parameters to see where things started to break down. So being as opportunistically lazy as I am, I thought it would be a really good idea if we put JQ transforms in the middle of all this, because we have it several other places in the system to manipulate these tasks as they're done. And additionally, we added the idea of having a blob of global data with values that you could use across the board. For example, like if you wanted to put contact information in the reference field, so that if somebody saw your task and they can say, "Oh, Matt Zukoskis is running this, let me email him and tell him it's messing our systems up." So that's kind of the introduction. That's kind of what this thing is and what it does for you. And let's talk about how to cook up a batch with this thing, how to actually do some batch processing. The batch processor's workflow is fairly straightforward. It begins with some input, and the input consists of the global data that we talked about a second ago, and we'll talk about some more later. And it also consists of a list of jobs, and jobs are just things that you want the batch processor to do. So you might do some latency tests and a throughput test and maybe a round trip time test, and those sort of become your jobs. These are all handed in bulk to the batch processor, which picks them apart and does a whole bunch of things with them, and we'll talk about that more in detail in a second. And they all get handed off to pScheduler, which carries out the measurements and produces results that are all collected by the batch processor and sent out as output. Now you'll notice that the output here looks very similar to the input. It's really sort of a value add proposition. So what you get here is what you put in plus the results added, so that you don't have to go back and match things in the output to the input. So you get what you already had. So the input, here's where we start piling a lot of JSON on. The input, like most things in pScheduler, is a blob of JSON. And it has a couple of sections in it. The first section is called the global section, and that's where all the global information lives. Inside of that is a section called data, and this is data that's made available to every transform that gets used in the batch processor, and that appears in a variable called global that's all pre-set up, so you don't even have to do anything. So, for example, if you had contact information in there, you could just access it, as global.contact information or whatever you set it to. There are also a couple of transforms, and I'm just going to kind of show them both to you here. There is the pre-transform and the post-transform. And I'll show you in a future slide how all these fit in. But the pre-transform is done before any specific job gets to do its own transforms, and the post-transform is done afterward. And this is useful again for things like putting contact information in the reference material, things like that. Things that you want to do maybe to every job that you do, but don't want to have to rubber stamp it. So in addition to the global section, there's also an array of jobs. And as you might guess, I'm not going to put all the details in here because this would become unreadable. But we'll talk about, in the next slide, we'll talk about what those jobs look like. So again, each job is a blob of JSON because that's, as we do. And those have in them, I'll show you, this is kind of a subset, but I think it's enough to get you started. It has a switch in it called enabled, which was something that I put in for development, and that just lets you turn jobs on and off without having to try to do anything kinky with comments or anything else like that. Each one has a label that largely feeds the debug. When you turn debugging on, it'll say, hey, I'm running this job. And then you get a task, which is just a bog standard pScheduler task specification. In fact, this can actually be what you export from what I talked about earlier, what you export from the command line interface. If you're comfortable with that, you can just kind of spit that out and plaster it in here. And those look, pretty much like you'd expect. You have a test specification that has in it a type, and then the spec itself. So in this case, we're going to do a round trip time to www.perfSONAR.net, and we're going to do it. We're going to do a 5 count of pings. The output of each of these jobs is again JSON, and what you get back with that is the original input. So you'll get the whole spec that I showed you on the previous slide, and you'll get another thing added to it that is an array of results. Now, because it is possible, I'll show you this in a minute, but because it's possible to have a job run multiple things, you actually can get multiple results back. So you'll see several of what I'm about to show you, depending on how many things you run. So in this case, what you get back in each result is 3 things. You get the result as raw JSON. So this is what came raw out of pScheduler and is good for machine readable applications. You get plain text, which is the same text that you see when you run the command line interface, and you get, say, a throughput result back, and you get the thing that looks like the iPerf output. And so that's good for humans. And you get an HTML rendering as well, which is not actually something we use anywhere in the system at the moment. But it's kind of just very generic HTML that you can embed in something else if you want. And that's good for humans who are sitting in front of web browsers. So the next the first trick I'm going to show you is how to do multiple measurements and how to do transformation within your jobs. So again, we'll start with our usual blob of JSON. One of the things in a job that you can add is a parameter called iterations, which will tell the batch processor how many times to run the task that's specified below. Additionally, there's a switch where you can tell it to run them in parallel or run them serially. So for example, in this case, we're just going to do a task where we're going to run 3 round trip times to the perfSONAR website. Now, in isolation, that is not particularly useful because it's going to be one right after the other, and the network conditions are probably going to be about the same. However, what you can do is you can add a transform. So this is the task transform, which operates on the task, and it is a standard pScheduler type JQ transform that's described in the documentation. And in this case, what we're doing is we have a script where we take the test spec and we add a count to it, and that's a calculated value based on a value or a variable that the batch processor provides called iteration. Those just go from 1 through 3 because we have 3 iterations, and we multiply that by the increment value that's in the global data. This is something that you as the end user would put in there. So, for example, if you wanted to do round trip time tests where you did 5 pings, then 10 pings, and 15 pings, you could set your global increment to 15, and JQ will do the math and put that in there, and you'll get 3 different tests you'll get three different tasks that do each one. So I mentioned that there was a little bit of workflow to this, and there is. So let me talk about that a bit. So what all this starts with is the task that's in the job that we just looked at a second ago. The first thing that gets applied is the pre-transform from the global section. The second thing that gets applied is the job's task transform. So it gets so in addition to the input, it gets the iteration as well, so that you can tell which iteration you're in, and then following that, you get the global post transform. So you have an opportunity to kind of do things globally before and after the task has its way with the data. In addition to all this, all 3 of these transforms have access to the global blob as well. So you can you can pull values from that if you want to do any kind of fancy calculations or anything. So what comes out of that is actually the final thing that's handed to pScheduler. So for example, as I said before, you can do things like you could do this was brought about by Matt's desire to do the same test repeatedly with ever increasing values in them as part of the parameters. This is kind of a too clever by half trick, but it actually does work, and that's how to do different tasks in parallel with this thing. So this is going to be kind of a two-parter here, but inside of the global block, inside the data block in there, you could create an array, for example, called my tasks that has in it 3 different tasks. So you could do, for example, you could do a round trip time, you could do a throughput and a latency, for example, just to make it different. In the job, what you would do is you would still say 3 iterations, and one of the things where this is deficient is the fact that we can't determine that programmatically, and that's something I intend to fix in the 5.0 release. There's also another switch that says whether or not they're in parallel. Talked about that. And then what we did here was we just started with an empty task. So that has absolutely nothing in it. So right now it's not really a valid job because there's no task in it. However, if you add a transform to this task, like we did in the previous thing, what we can do with it is we can extract from the global data part from the my tasks array that I showed you on the left there. Based on whatever the iteration is, you can set up these 3 things to run serially or in parallel or however you want, and they'll all be different in the same job. Now, you really don't need to do these serially because you could just do 3 separate jobs, one after the other. It would have the same effect. But if you want to do things in parallel, for example, maybe run a bunch of latency at the same time that you're running throughput, and see how one affects the other. That's why you'd use something like this. And some of these, there's actually an example a lot like this in the documentation, so don't feel like you have to digest it right now. So the workflow for each of these jobs, because I'm using the word workflow a lot today, once you have the task finalized, so it's been through all the transforms and validation and so forth, it's run with pScheduler. pScheduler obviously will run it when it's ready, and when the results are ready, those will all be collected. Those show up in the job results, and that sort of becomes the final answer, as it were. Something that's going to be added in release 5.0 is a thing called the continue if transform, which has access to global as well. And the continue if transforms job is to figure out whether or not the batch should proceed. So it takes all the job's results as input, and you can do whatever manner of transforms or anything else like that you want on it. And it basically it's a thumbs up, thumbs down sort of thing. So if whatever bit of script you put in there decides that the next job should be run, it returns true. Otherwise, it runs false or returns false. Here's an example of a continue if transform. What this does is it's a little deep here because there is actually a lot of stuff in it. But what it does is it just digs down into the first run and it looks into the JSON version of what came out of it and looks at whether or not it succeeded. And that sort of becomes the basis for whether or not the batch continues. As I said, that is not in the 4.4 production code. It is in the pipeline for 5, and will be there. Actually, the code's already done and tested, so I can kind of guarantee that was going to happen. So finally, the last part of this is how to actually, now that you have all this input, what do you do with it? How do you make the batch processor do something? There are a couple of avenues for this. The first is by way of the command line. pScheduler has a command in it called batch, which will let you do a batch right from the command line. What it does is it takes the input, I'll talk about that in a second, and it runs the batch and just spits the output directly to standard out. You have a bunch of options that go with this. Some of these kind of parallel some of the things that are in the command line, in the command line in general for running tasks. You have a thing for determining who the assist server is, who you bind to when talking to that, who's the lead if nothing is specified. Usually by default we do that for we do the local host for that, but we made it an option so that it's not as there gives you some additional flexibility. You can set a bind address for where outbound requests come from if you have multiple interfaces. And there are 2 other switches, debug and dry. Debug will produce debug output to the standard error, and dry will do a dry run, which is does all the processing and does everything but actually run the jobs with pScheduler. So what you get out is sort of you can use that to just debug and see what kind of things are happening with it. And lastly is the input file, and kind of in true Unix style, if you specify it, the batch processor will just read that whatever file you specify. Or if you don't specify anything, it'll just take its input off of standard input, and it sort of becomes a filter. Underpinning all this is some Python code, because that's what it was written in. And so the command line interface is actually just written is just written as a nice veneer on the Python that does this. So if you want to invoke this from a Python program, it's obviously Python 3 because that's what we support now. I've imported JSON because I'm going to use it for in a minute. But the important thing that makes this work is importing the batch processor object from the pScheduler batch processor library. Once you've imported that, I'm just going to assume that there's a batch specification here because I don't want to clutter the screen up. So we assign that to something. And basically the way you make this happen is you create an instance of the batch processor and you give it the batch. And the way you get a result back from it is you invoke it as if it were a function. So it will go off, do its thing, and return exactly the same results that you would have gotten if you did this on the command line. So finally, just sort of for completeness, I'm calling the JSON dump string method on the result, and we just send that to standard output, and that's the whole program. Obviously, because it's just a big structure full of stuff, you can do whatever you want with your programs to make them work for you. So I'm going to kind of blow through the rest of this. Oh, actually, I only have 2 slides left. So there are some optional arguments for these when you invoke it. Obviously, you have to give the batch processor a batch to operate on when you instantiate it, and you get pretty much the same sorts of things that you got on the command line because again, one is based on the other. So you get assist and lead and bind for that, and then similarly, when you invoke the batch processor, you can tell it to do a dry run. Or you can also provide a function that it'll call when it has a debug message for you. So futures, just real quick. So in 5.0, we're adding the continue if transform, and I will probably come up with a way to make the parallel jobs feature smarter so that you can specify the number of iterations. Later, if there's demand for it, and this is sort of a big if because I don't want to go to the trouble of implementing it if nobody wants it, we could implement a REST interface for that. Peashooter had a REST interface, and actually, to be really honest, if we did it for this, it would largely just be sort of a refactor of that. And I'm also considering whether prior jobs results are something that we want to have. We want to have the transforms have access to, but somebody would have to come to me with a use case for that and say, "Hey, I really want this." So that's kind of the batch processor in a nutshell. If anyone has questions, I'm gonna stop sharing my screen here so that I can see if anything interesting came up.
And there's nothing in chat yet, but we can wait a minute here for people to type.
Okay. Yeah, I know that was a lot of material, and there's, like I said, there's examples in the documentation. And I would also have to imagine a few people are going, "Hey, I didn't know we had this. Let me think about all sorts of interesting use cases for it." So, and you can feel free to, let's see, can the batch processor be used for TWAMP results processing? You can use it to run a bunch of TWAMPs if you want. And you'll get the results back, and of course you can do whatever you like with them. So I guess the answer is kind of yes, but the batch processor itself doesn't do anything. It doesn't do anything with the results.